So how do we tackle these challenges? These are some of the major ways in which we can tackle these problems. One is use better chunking strategies. You can do hyperparameter tuning. This is something a lot of folks actually don't do, but it can be quite effective. You can play around with the chunk size, retrieval strategy. Of course, you can use better embedding models. You can use advanced retrieval strategies. And I've talked about this with a lot of people as well as companies. Don't just use the default settings of the libraries or tools you're using. Don't just use cosine similarity, right, or embedding cosine similarity. Try more advanced strategies also if things are not working. Use context compression strategy. That is a great way to filter out unnecessary information from the context before you send it to the LLM to generate the response. And you can use better re-ranking models also. So you can experiment with various chunking strategies. The top one is the most commonly used one. You must have seen in tutorials and so on, in LangChain especially. But people don't know often that you can use token-based chunking also. You don't have to always split based on the number of characters of the words. You can split based on various tokenizers. Like, if you're using a GPT model, you can use a GPT tokenizer from TikTok, and Spacey has a lot of tokenizers, so then you can create chunk size based on number of tokens also. Sentence transformers, similarly, we just saw unstructured I/O. You can use it to load the data as well as do chunking based on sections and so on. Next one, very useful. Don't hesitate to do hyperparameter tuning. So how do we do that? Let's say you have your context and the question. The answer is separate. Let's say that's like you have some test cases where you have a golden or a reference answer created by humans. So what you can do is you can play around with the chunk size. You can try different chunk size values based on the number of tokens or characters. And each time you run, you will create a vector database collection instance. The next part which you see is where you can play around with the retrieval strategy. You can try different similarity techniques. You can play around with the top K document chunks which should be retrieved. You can play around with the similarity threshold, like, okay, don't return documents with less than 20% similarity to the question. And of course, then you send it to the LLM, generate the answer, compare the answer with the golden answer, and you can use various evaluation metrics. A lot of libraries out there, Deep Eval, Ragas, you can use all of these libraries and use various metrics, retrieval and response generation metrics to see which set of hyperparameters work well. Better embedding models. How do you choose a good embedding model? Go to the MTEB leaderboard, massive text embedding benchmark leaderboard. You will always find some of the top open source as well as commercial embedding models which you can play around with. But don't just choose it blindly, test it with your data. Okay, experiment yourself, very important, because benchmarks will always be benchmarks, right? Like in research papers, we have seen that. It might not work well on your data, but it's a good place to start to find the top models to use. Newer embedding models will always be trained on more data and will often be better. That's a given in most cases. And like I said, don't just go by benchmarks, experiment on your data. Don't use commercial models if data privacy is important. Like if you're using the OpenAI embedding model, it'll send your text documents to their servers. So if your data privacy is very important, don't use those kind of models. Go for the open weight or open source models. Advanced retrieval strategies. Don't just go by only cosine similarity, which you see on the top left. That is just simple cosine similarity. Try other kind of retrieval strategies. Number 2, top right, which you see is semantic similarity thresholding, where you do, let's say, cosine similarity or maximal marginal relevance ranking, and then you apply a threshold that, okay, similarity less than 20%, don't retrieve. Multi-query retrieval. Multi-query retrieval is where you ask the LLM to generate variants of your initial question so that you can retrieve more relevant context documents if possible. We'll cover this also in the hands-on. Hybrid search, very useful when you have documents where keywords are very important, like the RAM size, the processor number. Those cases, just cosine similarity may not work out, which is just semantic similarity, right? Semantic means meaning based on embeddings. So that is where you can go for hybrid search, which is a combination of keyword search, TF-IDF, BM25, and embedding search, right? That's cosine, any kind of semantic search. That's the number 5, which you see here. Reranking. Reranking is a way in which you can send the retrieved context documents and your question and get a relevancy score, the number 4 which you see there, in terms of which documents are actually relevant to answer the question. Relevancy is different from similarity. Similarity is just embedding similarity. Relevancy is more in terms of, can it actually be relevant to answer the question? And chained retrieval, where you can combine multiple of these steps. Better re-ranker models. Re-ranking is often very useful. They are nothing but fine-tuned cross-encoder transformer models. These models take in a pair of documents, usually your question and a context document, and they return back a score of how relevant is the context document to your question. How related are they? Higher scores are, of course, better. Models fine-tuned on more pairs and released recently will always be better, just like embedding models again. So in this case, as you can see in this diagram, we are first retrieving context documents, then re-ranking them by passing each of them with the question, getting the score, and then we can accordingly reshuffle them. Context compression strategies. If you have a lot of data in your retrieved chunks, it can sometimes confuse the LLM. So you can use various ways to reduce the context documents. How do you do that? Prompt-based compression, usually. So you can use an LLM and a prompt-based context compression. There are 2 strategies. Extractor means from the documents, remove parts of the document not related to answer the question. Filtering strategy, just remove entire documents which are not relevant to answer the question. So it's using an LLM here to do this. Similarly, Microsoft LLM Lingua is another one. You can check it out. It's open source. Again, prompt-based compression. Like in this example, you can see we have retrieved 3 context documents to answer the question, what's the capital of India? And we are using a filtering prompt-based context compression. It just removes Mumbai and Kolkata because they are not related.